welcome back to the YouTube channel for Heikia. So today we're going to be doing equivalent expressions. I haven't been recording for a while, so I might not be up to notch with this video. Okay, so today's learning intention, which you should be writing down in your books, is to be able to determine whether two expressions are equivalent using substitution. Okay, let's see if I can use my pen properly. Today's success criteria is that you need to be able to know what it means for two expressions to be equivalent. So, which I'll talk about what that looks like. You need to be able to substitute values into an expression, and you need to be able to find equivalent expressions using substitution. Okay, so this is a general definition that I've come up with for equivalent expressions. So it can be said as two expressions are called equivalent when they are always equal, regardless of what numbers are substituted for the pronumerals. So pronumerals is like the fancy word for the letters we use. Alright, so for example, x plus 12 is the same as saying 12 plus x, but you can also say, 3k is the same as k plus k plus k because there's 3 k's. So here is a table, and you've got your expressions up the top. So these are the expressions. Okay, and over here you've got these values that you need to use to substitute into A. So, when A equals 0, okay, the equation equals 5. When A equals 0 here, the equation will equal 6. So I will show you how to work it out in the next few slides. But first, what we need to just be able to look at is by looking at this table, we can see that 3a plus 5 is a equivalent expression to 7a plus 5 minus 4a. Okay, and how we can tell that by looking at it is that these values here are the same as these ones. So when you sub in the same number for both the expressions, they equal the same. So when a equals 0 here, it equals 5. When a equals 0 in this expression, the expression also equals 5. Now sometimes, okay, they will be very exact for the first two values, but then the third value might be different. So like when you sub a equals 2 into an expression, it might be different, and that's not an equivalent expression. So they must be exactly the same no matter what value you're substituting into a. So these two are equivalent, but so are these two. 2a plus 6 and a plus 6, they are also the same. As you can see, 6, 8, 10, 12, 14, 6, 8, 10, 12, 14. So they're the same. All right. Now remembering you can pause this video at any time if you need to, and you can go back and replay anything that I've said if you feel like I've been talking too quick. Okay, so for the first one, you can see that the expression they've given us is on the left side. So before it was at the top, but now it's on the left side, all right? Now it shouldn't matter at the moment, because right now we're just going to call this a substitution table, all right? So what we need to do is I'm going to do the first row in red, and then I'm going to do the second row in a different color, which I'll select later. So when x equals 0 for the first equation, so it'd be 2, okay, so the equation is 2x plus 2, but when I put 0 into it, okay, that's me putting 0 into x. Now I've put it in brackets just to show you that that's the value I'm putting into x, okay. The reason why I wouldn't do 2, 0 is because when I am in a rush or I'm feeling under the pressure, that might actually look like, well, the number 20, okay. And that's not what the value is. So the symbol that joins the number and the pronumeral, which is the letter, is a multiplication sign. So with that said, 2 times 0 is 0 plus 2. So we know when x equals 0 for that expression, it equals 2. All right. So for this one here, Okay, we can do, so the question is 2x plus 2, so we know that we want to substitute 1 in there. We know there's a multiplication sign that joins them together, so 2 times 1 is 2, plus 2, which equals 4. Okay, and we can fill out the rest of the table, which I will do for you. So 2x plus 2, you're putting 2 into the value, okay, and so 2 times 2 equals 4 plus 2, okay, so 4 plus 2 is 6. And we can see a common pattern, so 2, 4, 6. All right, now, I would presume this would be 8, but we can always check. It doesn't hurt to check, especially when you're feeling under the pressure. So 2 times 3 is 6, plus 2 is 8. All right, and there's that pattern there for you. So now I'm going to fill out the next row in green. I'm feeling a bit Christmassy. So let's fill out the first one here. All right, so the equation is x plus 1 times 2, but x equals 0 for this one. So we're going to put 0 plus 1 times 2. Okay, so that 0 plus 1 is 1 times 2, which equals 2. So we know this one's 2 as well. And for this one here, all right, I'm just writing the question out just so you can see it. You're more than welcome to also write these in your books. So x equals 1. So you put the 1 down as the x. So 1 plus 1 is 2 times 2, which equals 4. All right, so let's do this one over here. When x equals 2, so the equation is x plus 1 times 2. So when x equals 2, meaning you have to put the 2 down as x, you just copy down the same equation. So 2 plus 1 is 3 times 2. So 3 times 2 is 6. Okay, we can see a pattern here. Now, I could presume that this one is 8 as well, but I will double check. Okay, so this is when x equals 3. So we put 3 down as x plus 1 times 2. So 3 plus 1 is 4 times 2, which equals 8. All right, and looking at these values here, in the top row in red and the values at the bottom in green, we can see that both the expressions are equivalent, because no matter what value you're substituting, they are equal. Okay, so these two are equivalent expressions, and we do need to get into this habit, especially for the exercise that you'll be doing today, because that will involve you being able to identify if two expressions are equivalent or not. Alright, so I'm going to do the same colors as before, just so we're not confused. So the very first one, you have 5x plus 3, that's the expression we're given. So we have to substitute 0 as x, and I've just put it in brackets just so you know that it's not 50, it's actually 5 times 0. Because actually, if I was to take that out and expand it, it would look like 5 times x. And yes, you do need to get in the habit of writing x as, a backward C and a forward C, I suppose. Because if I was to just write 5 times x, see the difference between those two? And that's not what we want. Okay, we want something like this, not something like that. So now, going back to the equation, 5 times 0 is 0 plus 3. So 0 plus 3 is 3. So we put 3 in there. All right, and if we fill this one out, 5x plus 3 when x equals 1. So we put the 1 in as the x. So 5 times 1 is 5 plus 3. So 5 plus 3 is 8. All right, and then we fill this one out. So 5x plus 3. So you need to be making sure that you show all your working out, because it is quite common for you to just jump to the conclusion and do it in your head. Like, oh, I know 5 times 2 is 10, so I'll just write 10 plus 3. And you might skip, that step. And we really want to see your working out. All right. So just make sure your equal signs are aligned. I'm having a bit of difficulty at the moment because I am trying to do it on a tablet which I have not used for a few weeks. I'd say close to a month, maybe. So 5 times 3 is 15 plus 3, which equals 18. Alright, so now that I've done the top one, I can do the bottom row for you. So let's do that one there. 6x plus 3. So when x equals 0, okay, 6 times 0 is 0 plus 3, which equals 3. All right, and you just need to get into the habit of practicing, showing you're working out, and just making sure that you can do it with quick speed. So 6 times 1 is 6 plus 3, and I forgot to put the question up the top for you. So 6 plus 3 is 9. Okay. So 6x plus 3, when x equals 2, we're looking at there. So 6, 2 plus 3, 6 times 2 is 12 plus 3. And we do these first, not because it's only because it's in brackets, but also because it's multiplication. And we usually do multiplication before we do addition and subtraction. So 6x plus 3, so you substitute 3 into there. There is a multiplication sign that joins them, so 6 times 3 is 18 plus 3, so 18 plus 3 is 21. Alright, and now we've got our values for the first expression and the second one, and we can see that they aren't equivalent expressions because they do not have equal values when substituting the same numbers into both of them. So these are not equivalent expressions. It's good to just take note so that you know the difference. Okay, so for this one I've actually completed the table for you. And I'll do back to red. Okay, so which two of these expressions are equivalent? So I've put the 1, 2, 3, and 4 expressions on the left. So we have the equivalent expression, we have the expressions on this side. Okay, and we have the values on this side, the values that we're substituting. I'm going to call them substitution values. Okay, now if you wanted to put these values on the left side and put the expressions up the top, that's also okay. I've just gone with the same one as worked example 1 and 2 because I just want to keep it consistent. So I've substituted a equals 1 into all of these values and I got 8. So when you look at that, you go, well, they could potentially be equivalent expressions. When I substituted a equals 2 into all of these expressions, I got 10, 14, 10, 16. So at the moment, okay, we can see all of them have 8. But now we can only see 2 of them having 2. So only these two look like they would be equivalent expressions because they have the same value when you substitute a equals 2 into their expression. Now when I substitute a equals 3, okay, I see 12, 20, 12, 24. And we can see that these 12s here are the same number. So we could say, okay, therefore, after you've solved all of this and shown you're working out, you would write 2a plus 6 and 8 and a plus 3 times 2 are equivalent expressions. Okay, so just wanted to repeat that this 3 dots that look like a triangle stands for therefore. Okay. So that's something that you need to get into apart from showing you're working out here, which I could have done, but it'd be quite messy. You also need to have a concluding sentence to state which one is equivalent. And that is all for today. So hopefully you did learn a bit of tricks on how to substitute values and how to write the values in and show all your working out. If you have any questions, feel free to ask your teacher. Thank you.